In the context of an upstream oil and gas plant and oil well instrumentation, it's crucial to ensure reliable and accurate measurement and control to maintain safety, optimize production, and minimize downtime. Below are the critical factors to consider for various types of field instrumentation. Pressure instruments. 1. Range and accuracy. Ensure the pressure instruments can measure the full range of pressures expected in the system with the required accuracy. 2. Material compatibility. Instruments must be made from materials that are compatible with the process fluids to prevent corrosion and ensure longevity. 3. Temperature effects. Consider the effects of temperature changes on the accuracy and reliability of pressure measurements. 4. Response time. The instruments should have a fast response time to accurately capture pressure fluctuations. 5. Installation location. Proper placement is essential to avoid issues such as vibration, high temperatures, and accessibility for maintenance. 6. Hazardous area certification. Ensure the instruments are certified for use in potentially explosive environments, e.g. ATEX, IEC-X. 7. Redundancy and reliability. Implement redundancy in critical measurement points to ensure reliability and safety. Temperature instruments. 1. Range and accuracy. Select instruments that can accurately measure the full temperature range expected in the process. 2. Response time. The sensors should respond quickly to temperature changes to maintain control accuracy. 3. Material compatibility. Sensors must be resistant to process fluids and environmental conditions. 4. Installation and placement. Proper sensor placement is critical for accurate temperature measurement, avoiding areas with temperature gradients or hotspots. 5. Calibration and maintenance. Regular calibration and maintenance schedules to ensure long-term accuracy and reliability. 6. Explosion-proof design. Ensure that the instruments are suitable for use in hazardous areas. 7. Heat transfer. Consider the thermal mass and heat transfer characteristics of the sensors and their mounts. Flow instruments. 1. Measurement principle. Choose the appropriate measurement principle, e.g. differential pressure, ultrasonic, magnetic, based on the fluid properties and process conditions. 2. Range and accuracy. Ensure the flow meters can handle the expected flow rates with the required accuracy. 3. Pressure drop. Minimize pressure drop across the flow meter to avoid affecting the process. 4. Installation requirements. Follow manufacturer guidelines for straight pipe lengths upstream and downstream to ensure accurate measurements. 5. Material compatibility. Select materials that can withstand the process fluids to prevent corrosion and fouling. 6. Calibration and maintenance. Regular calibration and maintenance are necessary to ensure the accuracy and longevity of flow meters. 7. Hazardous area certification. Ensure flow meters are certified for use in explosive environments. Level instruments. 1. Measurement range and accuracy. Ensure level instruments can measure the full range of levels expected with the required accuracy. 2. Process conditions. Consider temperature, pressure, and chemical properties of the process fluid when selecting level instruments. 3. Measurement technology. Choose the appropriate technology, e.g. radar, ultrasonic, float, based on process conditions and tank geometry. 4. Installation location. Proper placement is essential to avoid interference from tank structures or turbulence. 5. Redundancy and reliability. Implement redundancy in critical level measurements for safety and reliability. 6. Calibration and maintenance. Regular calibration and maintenance are necessary to ensure accuracy and reliability. Safety considerations. Ensure that level instruments are suitable for use in hazardous areas and can handle overfill or low-level conditions. General considerations for all instruments. 1. Environmental conditions. Consider ambient temperature, humidity, and potential exposure to corrosive or explosive atmospheres. 2. Integration with control systems. Ensure compatibility with the plant's control systems, e.g. DCS, SCADA, for seamless integration. 3. Data communication. Choose appropriate communication protocols, e.g. HART, Modbus, Fieldbus for reliable data transmission. 4. Power supply. Ensure a stable and reliable power supply for all instruments, with backup options where necessary. 5. Maintenance accessibility. Instruments should be easily accessible for routine maintenance and calibration. 6. Training and documentation. Provide adequate training for personnel and maintain comprehensive documentation for troubleshooting and maintenance. 7. Compliance with standards. Ensure all instruments comply with relevant industry standards and regulations. By considering these factors, you can ensure that the instrumentation in an upstream oil and gas plant and oil well is accurate, reliable, and safe, contributing to efficient and trouble-free operation.